The table below contains data from a study on vitamin C intake in children and the common cold. Find the probability that a randomly selected child has developed a cold given that he or she has been receiving vitamin C. So I've underlined the word probability to indicate this is a probability problem, and I've also underlined the little article A here because it says a randomly selected child, right? That means just one child, it's just one event selecting one child from the population, but then they have an extra key phrase here because at this point, with just this information, it would just be basic probability. But if we read on and we find the word or here somewhere, we'll think it's addition rule of probability. But we don't see an or either. And if I read on further and I see that there's the phrase given that, or that idea is implied in the problem, then it would be conditional probability. And so with this key phrase here, combined with the fact that it's just a simple event of selecting one individual, this is the most basic case of conditional probability. One event, and we have this phrase given that. All right, so once we know it's conditional probability, and we have a table involved in the problem or involved in the layout of the problem, we can then at that point do a very simple shortcut. And that shortcut involves simply focusing on the part of the problem that involves the given that condition. So only look at the part that follows this phrase given that. And this is given that he or she has been receiving vitamin C. So let's find the column or row in the table that corresponds to that, and let's indicate that somehow. So what I'm going to do is come along and say, okay, we're looking for the people who have been receiving vitamin C. We're only interested in that group. So I'm going to say the vitamin C group is the only place that I should look at to solve this entire problem. If I take any number outside of these three values here that are related to the vitamin C group, I'm making a mistake because it says, given that she has been receiving vitamin C. So I'm only interested in the people who have been given vitamin C. That's only the people in this column. All the other numbers here are useless to me. I only care about the people that are in the vitamin C group. And among those, I would like to know the probability that the person develops a cold. Okay, so let's write out this probability statement. I would say probability that a randomly selected child develops a cold. So I'm going to say probability of a cold given that they have been given vitamin C. This is my probability. Probability of a cold given that they have been given vitamin C. Okay, now, again, a single event, this problem will be solved with a single fraction. We're going to have on the bottom the total always, right? So when I look at these three numbers, the only three numbers I should be using to solve the problem, I want to identify the total. So this is not a total, this is not a total, the only total is the 57, so that total becomes my denominator for the problem. These are all the people in the study who were given vitamin C. Now from there, after I have that done, I want to identify from the remaining two numbers that are left that I haven't used yet, which one corresponds to having a cold, right? Children free of colds or children developing colds. So it's this group, the children developing colds, and therefore that number 36 that goes on top. So it's so nice when you have a table and you can use that shortcut. What's the shortcut again? Focus only on the phrase that follows the given that condition, right? So he or she has been receiving vitamin C, so we only look at the vitamin C group. And then among those, we want to find the ones who developed colds. Children developing colds, 36. Our total for that group is always going to be our total for our fraction, and we're done. Just figure out what 36 divided by 57 is, and you have your answer. So 36 divided by 57, we end up with the answer 0.632. Or in other words, approximately 63.2%.